In this video, I am going to determine whether the given functions are exponential growth or exponential decay. Before I talk about the exponential growth and decay, let me give you an idea of what it means. An exponential growth, it looks like this. As you go from left to right, the function grows exponentially like this. An exponential decay means the following. As you go from left to right, the function decays like this. Keep in mind, this never touches the x-axis and this never touches the x-axis. So the yellow one is exponential decay. As x progresses or as x increases, the function goes down, and the blue line or the blue graph is the exponential growth. Now let's go ahead and address each of these problems individually. So A, we are given y is equal to 2 to the power x. If we compare this to y is equal to a to the power x, then we obviously see that a is 2. However, what makes this y is equal to a to the power x exponential growth, and what makes it exponential decay? Now let me take this and put it in perspective right here. When your a is greater than 1, then it's going to be an exponential growth. That means it's going to look like the blue curve. When your a is between 0 and 1, 0 is less than a is less than 1, then it's going to be an exponential decay. So once again, let me summarize this little thing. It's important. When your a, the base, when this base is greater than 1, then it's going to be an exponential growth as this one. When a is less than between 0 and 1, that means it's a fraction, then it's going to be an exponential decay like this one. So now in our case, what is my a? My a is equal to 2, so this is going to be an exponential growth. Now let's do b. 2 to the power y is equal to 2 to the power negative x. But this is not like y is equal to a to the power x right here. It has negative x. So we need to kind of restructure it in such a way so that it fits this format. Y is equal to a to the power x. So we can do it by just using the definition. This is 1 over 2 to the power x, which is the same as 1/2 raised to the power x. Now if we compare this to a to the power x, we obviously see that a is 1/2, which is, by the way, between 0 and 1. So this must be an exponential decay. C, e to the power negative x, which is the same as 1 over e to the power x, which is the same as 1 over e raised to the power x. If I compare this to a to the power x, a is going to be 1 over e, which is once again between 0 and 1. So 0 is less than a is less than 1. Here a is greater than 1. Once again here 0 is less than a is less than 1. Remember, e is equal to 2.7172 and dot dot dot. And 1 over e is a positive number between 0 and 1, so it must be exponential decay. Okay, and part E is 1 over e to the power negative x. We kind of need to simplify it. This is going to be 1 over e to the power x. If I flip it, it's going to be 1 times e to the power x over 1, which is just e to the power x, correct? Now as we can see, if I compare this to a to the power x, my a is equal to e, which is greater than 1. So this must be an exponential growth. And this is how you determine whether a function expressed in the form y is equal to a to the power x, is it an exponential growth or exponential decay? I hope that this discussion was helpful. Thank you very much.